Good morning. This recording is for Pre-Algebra Chapter 6, Lesson 3, not 4. Similar figures and scale drawings. This is a 3, by the way, guys. There we go. So, similar figures and scale drawings. Similar figures have the same shape, but not necessarily the same size. Similar figures have corresponding angles and corresponding sides. That means that one side on one of the figures is going to be very similar to a side on the other figure. Okay, so here we have two figures. We have two triangles. And we know they are similar because they have corresponding angles. Angles on similar figures are actually exactly the same. So we know that here, 64 is the same as the 64 here. The 61 here is the same as the 61 there, and the 55 there is the same as the 55 there. Those are corresponding angles, all right? And we also know that they're similar figures because not only do they have corresponding angles, but their sides form proportions. So if I was to do big over small, side AB over side XY, or 8.3 over 12.4, it would form a proportion with big over small on any of the other sides. Either 9.1 over 13.6, or 10 over 15. Okay? So they all go together. There you go. All right. So again, those are similar figures because they have corresponding angles and corresponding sides. And this little wavy line here means similar to. So I could say triangle ABC is similar to triangle XYZ. Now also notice that they are in order. And they're not only in order alphabetically, but they're in order by which angles go together. So angle A goes with angle X, which is why they're both first. Angle B goes with angle Y, which is why they're second, and angle C goes with angle Z because they are third. So again, the order that the letters go into when you're saying they're similar actually tells you which angles are similar to each other and that they go together, all right? Since angle A goes with angle X, they go together in the same order. So again, if I say which angle on triangle XYZ is the similar angle to angle C, you just need to look at which position the C's in and then look at the position, the same position that the other angle is in, which in this case is Z, to figure out that Z and C are the similar angles to each other. All right? So again, corresponding angles have the same measure, and the lengths of corresponding sides are proportional. All right, and again, remember, proportional are two fractions that equal each other. So I could say 8.3 over 12.4 is equal to 9.1 over 13.6 because these two go together and these two go together, and that will form an equal proportion. All right, and I will show you a few soon. Okay, so let's go ahead and talk about these similar figures. We have two rectangles. Rectangle KL, we don't know about this yet. We don't know about the KLM because KLM is not up. All right, but let's go ahead and figure out X. Let's go ahead and figure out that one right there. So what I'm going to do is I'm going to set up a table. And you can kind of think of it like a Punnett square because I know at this point 7th graders are familiar with Punnett squares. So we're going to set it up kind of like a Punnett square where we're going to use the information where I'm talking about the small rectangle and the big rectangle, where the small rectangle has a long side and the small rectangle has a short side, and the big rectangle has a long side and the big rectangle also has a short side, right? So you can visibly tell that side AB is longer than side AD. Okay, so let's go ahead and make a Punnett square. It's kind of like a Punnett square. It's kind of like a fake Punnett square. There's your actual square, and it kind of goes like this and goes like this. But there's a big old equal sign in the middle, which you can't really see anymore because I'm using red on top of red. There we go. So there's a big old equal sign. Remember, we're doing with proportion, so we have a fraction equaling a fraction. So we're going to make a fraction using this information. We're going to take the big long side, which is side EF, which measures 24, and we're going to put it right there. And we're going to take side big short, which is the big rectangle, but the short side of the rectangle, which is 18, and make a fraction. Now we're going to take the similar information from small and put it in there. So we're going to say small long, which is 16, and we're going to put the x in since we don't know. So now we actually have a proportion. We have 24 over 18 equals 16 over x. So now we need to solve for x. All right, we're going to use cross product. So x times 24 is equal to 16 times 18. There you go. So let's go ahead and solve for x. So 18 times 16 is 288. Then we're going to divide by 24 to get x by itself. And guess what? X is 12. It must have been a mind reader. There we go. X equals 12. So now that we know what x is, we can actually compare the information we know to a new rectangle that hasn't been drawn yet. But we know rectangle KLMN is similar to rectangle ABCD. And again, order matters. So angle K of the rectangle goes with angle A. Angle L goes with B, M goes with C, and N goes with D. So let's go ahead and draw this. So there we go. So again, K goes with A, L with B, and M with C, and N with K. So as you can see, this looks, thing's a little, there we go. There you go. So it looks kind of like my rectangle, and the angles that correspond are in similar places. So K goes with A, L with B, C with M, D with N. And I actually don't know if you could see me move all of that business, but there we go. Let me put it back. There we go. All right, now that I've rotated it. Okay, so again, K goes with A, L with B, C with M, and D with N. So we know that side KL is 21. We want to find KN. All right? We want to find KN. So I'm going to set up the Punnett square kind of like I did with the one above, where we have the big short and the big long. Big short, big long. Right. And we're going to start filling it in. So the big long is 21. The big short is question mark, don't know. And the small long is 16, and the small short is 12, since we figured out 12 from the previous problem we just did. So cross product, yep, and 21 times 12 equals 16 times x. That equals 252, divide by 16, x equals 15.75. So the short side of this new rectangle is 15.75. All right, let's move on. All right, so we can use some scale drawings to find indirect measurements and properties of similar figures. And this will help us determine hard to measure items. And actually, they use this all the time when it comes to satellite photographs. Story time, Misty H., when she was in high school, had an Algebra 2 teacher. His name was Mr. Mace, and he was a former Navy SEAL. And not only did he tell us interesting stories about when he was at training to become a SEAL, which is actually a lot of classroom time, he, along with blowing up San Diego, hypothetically, using a nuclear bomb, which was very cool, because I lived in San Diego, and it was kind of interesting to hear what type of damage would happen. He also said that he used this exact type of information and skill in math to determine sizes of things from satellite photos. So if they had a satellite photo of some bad people, well, supposedly bad people, because they're not really bad, I guess, until proven guilty, whatever. So if you had a satellite picture of this building where supposedly bad people were hanging out, but he didn't know the size of the building, he could figure out the size of the building based on information that he knew about things that were around the building. So let's say there's this old VW Bug parked out in front of this building. Well, they know how big a VW Bug is because they were only a certain size dimension, and then based even on year, they could get a really good estimate on the size of the car, and then based on the size of the car, they can then figure out the size of the building. The same way we're going to do it here. The building that is 70 feet, because we know it's 70 feet high, casts a shadow of 150 feet, because we measured it. A nearby flagpole casts a shadow of 60 feet, and we're going to draw a diagram to determine the height of the flagpole using proportions. So here's a building and its shadow. Here's a flagpole and its shadow. Remember, and it basically, remember, this is like a triangle. This is how we know they're similar figures. It's not just two angles that we're comparing. We can actually draw little triangles. So they're similar triangles. So the building is 70 feet. The shadow is 150. We don't know the flagpole height, but we do know the shadow of the flagpole is 60. So let's go ahead and make a proportion. The height of the building over the height of the flagpole is equal to the shadow of the building over the shadow of the flagpole. All right? So 70 over question mark is equal to 150 over 60. Cross product, 70 times 60 is 4,200. 150 times x is 150x divided by 150. That cancels out, and x equals 28. So the height of the flagpole is 28 feet tall. All right, last thing we have to do. A scale drawing is an enlargement or reduction drawing that is similar to an actual object. So it's either bigger than what the actual thing is or smaller than what the actual thing is. So when you're looking at like a map of the state of California, it is a smaller or reduced drawing that is similar to the actual state of California, unless, you know, your 2-year-old sister or brother drew it, then it's probably not very accurate. But, you know, they had the right idea. Okay, so the distance from Sacramento to San Jose is about 121 miles. What is the approximate map distance between the two cities if the map scale is 1 inch to 44 miles? So if we're looking at a map of the state of California, and the scale says that for every 1 inch on the map, it represents 44 miles in real life. We know that in real life, San Jose to Sacramento is 121 miles. So we're going to use this information to create proportions. We're going to have a fraction for the scale on the map, and we're going to have a proportion for real life. So, and then we're going to have inches on top and miles on the bottom. So in inches on the map, we say that 1 inch is equal to 44 miles, and this whole thing is going to equal real life. Well, we know in the real life, in the real world, it is Sacramento to San Jose is 121 miles. But we don't know in the real life how many inches it is on our map from Sacramento to San Jose, or vice versa. So we set up this proportion. 1 inch over 44 miles is equal to x over 121. Cross products. All right, so that is basically, and here I'm going to show you how the units cancel out, okay? So we have 1 inch times 121 miles is equal to 44 miles times x. Well, you know that x needs to be inches because that's what the question's asking you to find. But this is how it actually works. So 1 inch times 121 miles is 121 inch miles. Yes, I said inch miles. Now, if we divide by 44 miles on the left, or excuse me, on the right, and do the same on the left, because what you do on one side, you have to do the other, the miles on the right are going to cancel out, and the miles on the left are going to cancel out, leaving me just inches. So, it's going to be 2.75 inches between Sacramento and San Jose on the map. Okay, I'm done. I told a story. All right, I'll be quiet. Bye, guys. Good luck.